Hello, I'm John Barrett, and I'm one of the faculty members here at the School of Nursing, and today we're going to be demystifying statistics. Our topic is confidence intervals. So what are confidence intervals? Well, a formal definition is, given the observed difference between experimental and control groups, what is the plausible range of differences within which the true difference might actually lie? A more down-to-earth explanation is a range of values that is likely to encompass the true value or the effect of the intervention on the entire population. I still think that's not completely clear, but I think if we apply an example, it will be much more clear and something that will help you understand confidence intervals a little better. So let's take a look. So we look at this example, which is a study in 1997 that looked at people who were prescribed the DASH diet versus the typical American diet. So the people who were on the typical American diet would be considered the placebo, and they actually saw a decrease in systolic blood pressure by 0.6. On the DASH diet group, they saw a much more significant decrease, a decrease in systolic blood pressure by 11.8. So in the lower right-hand corner, you see this box here. That's 11.8, which is the DASH diet, subtracted from the typical American diet. So you see a change in systolic blood pressure favoring the DASH diet by 11.2. So let's apply that with some confidence intervals to help us understand. So this 95% confidence interval for this study showed that on average, patients could be expected to have a systolic blood pressure decrease anywhere between 6.1 and 16.2. So let me help you understand what this means. So we have a study, and we can obviously not get the entire population in the study, so we take a sample, a smaller sample of the population. And then we try to apply or predict what that sample would mean on the entire population, which is where you actually care as a clinician. You care on average, if you prescribe the DASH diet, would you expect your patient to have a decrease in systolic blood pressure? So let's take a look at that number again. So on the bottom, you can see this chart, 0 being no decrease in blood pressure in the center, negative 6.1 being the least amount of decrease you would see, and 16.2 being the most. And so you have a 95% confident, you're probably 95% confident that if you prescribe this to your patients, on average they would see somewhere between 6.1 and 16.2 decrease in systolic blood pressure. Well, this is important because if you consider worst case scenario, your patients would see a decrease at about 6.1, and if you consider the best case scenario, you would see negative 16.2, which is pretty significant. That's actually better than most medications that do when we think about decreasing systolic blood pressure. So let's take a look at another example. We'll make up some numbers and change them around on how else you can use this, because it's easy to see in this instance on why you might want to prescribe this diet. So if you take a look at this clinical application, I just moved the numbers to the other side. What would you say if on the worst, you could see an increase in systolic blood pressure at 16.2, and even at the best, you would see an increase at 16.1. So somewhere in this confidence interval, you're always seeing an increase in blood pressure. And so you obviously wouldn't be prescribing the DASH diet because it's actually worse than the typical American diet. But this is not the only place where it can help you understand whether or not to prescribe an intervention. Now, I'm going to change the numbers around just a little bit here again. What would happen if these numbers were the truth? What if it was negative 16.2, so you could see a decrease in blood pressure, a significant decrease, or on the other side, you could see an increase all the way up to 6.1. So that you are 95% sure that you can either see an increase or a decrease. You're not really sure if this intervention would help. So I would say, if I was looking at those numbers, I wouldn't be prescribing the DASH diet, because obviously the DASH diet could help or it could hurt someone with systolic blood pressure. So let's take a look at a couple of caveats about confidence intervals to help you understand them when you're reading trials. So confidence intervals in healthcare we tend to see three different numbers. First, there's 90% confidence intervals, which just basically means you have a 10%, you're 90% confident that the true number lies within that range. 95% confidence intervals, which are the most common, that means you have a 95% confident that the true numbers lie within that range. And on the 97.5% confidence intervals, you have an even narrower range. You're 7.5%, or there's a 2.5% chance that you would see a true number outside of the ranges that you see. Study investigators in healthcare research generally tend to use a 95% confidence interval. So you'll see that in literature, but you also might see these other numbers. So I hope this helps you understand confidence intervals and how you can apply them in clinical practice. They're a really powerful tool, and as illustrated there below. Let us know if you have any questions, and thanks for watching.